So this is the second part of this training video, and we're going to see now how raw BMA data is incorporated into the current structure. So there's already BMAs in here, there's already flows, there's already graphs, there's already all these things, and all that you want to do is you want to say, I want to add now a new gravity separation. So ineffective, you want to say this was the normal, this was the super LSR with the high monazite, and then we'll create a new one to say this is the super LSR with the reduced monazite, which represents this part here. So what we're going to do is we're going to look at the mass. So right, the mass is going to be updated, which is already done. It's in here, but what we do is we do update the BMA. The mag sep is already there. We'll update this flow, and we'll update then additional mag, a non-mag flow sheet, and then the total mag will also be updated. Okay, so let's start then with the BMA data. So if you look at the structure, how it was done, then you can see that this was the normal non-mag feed, and that was the super LSR that was done, and this is just the magnetic separation. So there's already a structure in place to say this is how this specific flow sheet looks. So the exact same flow sheet was followed, so you just copy this the exact same structure. So we'll insert it right in here. So all this work has been done, all these calculations has been done there. So we simply copy and paste it in there. We can delete those two lines. We can delete that. So that is no longer, just deleting that. And we're not deleting any calculations. We'll delete the actual values, and we have to update then these labels. So we can call this one, say this is super LSR, and we can call that low MZ, low monazite. Okay, paste that in there, copy, paste those values in there, and from the mass tab you can see that this is flow sheet 4. So we'll enter flow sheet 4 in there, so it's A4, and just paste those things, and then just check again the simple structure. Is it one shaking table, 2 coronostat, and so on? So let's quickly review that. It says it's if we scroll down here and we look at A4, then recombine all of this to make up a sample for a second pass RER. So the RER was done, and then there was a shaking table, so just a few corrections here. So this then is shaking table there, SHT, it's not a rare earth roll, and it is then 2 shaking table because one was RER. So if you go back to the flow sheet and say, right, this flow sheet A4 doesn't represent the mass flow, but for now we're going to just ignore that and say, all right, let's proceed then to say, right, A4 consists out of a RER, which was the recombined feed and the second pass, and that produced the new reduced monazite. And then the second one was then a 2 shaking table, 3 coronostat, 4 coronostat, and a 5th coronostat. Looking at the flow sheet, that looks like this, where you say you've got a shaking table, 1 coronostat, 2 coronostat, 3 coronostat. Okay, in total 4 processes plus the additional first one on RER makes it the 5 processes, which you can see then here, 1, 2, 3, 4, 5. Now a quick look at the mass balance here. You came in with 9.33% of the mass. Where does that come from? So you have to check, is a 9.3 originates from the back calculation. So if you look at the original, if you go to the back mass flow, then you say that was the 9.3 that was started off, and it was fractionated to the 8.1. So if you look at your flow sheet and you say that is the 9.3 and that is the 8.1, so that makes sense. Then you say, right, the shaking table concentrate goes through, and that is correct. That's the 3.6. Those masses ties up. Then the 2.5, which is on the non-conductor, that is checked there, and the 2.5 is correct. And then the 1.1% from the conductors is then fractionated to on the conductor side, which is correct. So looking at the quick format and looking at the errors, they say these errors are low, so they are acceptable. Checking your total mass balance check and say these errors are low, so they are acceptable. Then looking for your blue numbers and say, is that correct? Then looking at this one and say that one is just 160, and so that one must be 0 because there's no remaining mass. 84 BMA, 84 reference. These masses all, no open spaces. Okay, so it looks fine. Let's go then to BMA, and we add now the masses in the blue column. Now just a quick correction, it's not one shaking table, it was actually one RER was the first step on it, so we will have to just change this to 2 shaking table to be consistent with this sheet. But what I think I'm going to do is I'm going to undo that. I'm going to remain with this labeling and say I'm going to keep the same structure, because when we create the structure going forward, we want these labels to be more or less similar. So let's for the moment just use those labels because it's the same structure as on top. So what do we say? We've got a mid and a tail that's from a BMA. Where is that mass? So that mass comes from mass A4. It's the mid and the tail. So it's those two masses. So you can F4 and enter. And those are those two masses. Then you have the primary coronostat, which makes a conductor non-conductor. So where are those two masses? You can fetch them there. You say that is your primary coronostat. So it's those two masses there. And you enter. And then you've got on coronostat 3, you've got a conductor, mid, non-conductor. So those three masses, and you fetch them on your non-conductor. So it's those three masses, F4, and you enter, and then you say you've got the fourth coronostat, which is on the conductor side. And you press F4, and you look at that. You say, right, now a quick view in terms of does these numbers make sense, and say yes they do. No they don't. These numbers are very low in their mass percentage. So going back to A4 and say that 9.3%. Going back to the flow compare. Well, what we need to do is we need to, since these values are all expressed relative to 100 units, it's expressed in 100 units. So what we need to do is we need to say, right, the BMA data need to be expressed to 100 units, so that your shaking table head in all cases are 100%. So that shaking table head should add up to 100%. So how do you do that? You say go to flow sheet A4 and say, okay, so this is your Reyes roll feed. That's still fine, but the shaking table should now add up to 100. So this one, instead of referring to the previous one, what we do is we take that specific mass out. We can and fill those numbers up and say, right, now your shaking table is adding up to 100, and now all of the rest will calculate through because they are linked. And looking now at your BMA and say, all right, so you're comparing 3 of them, and these are the masses from your shaking table, and they add up to 100. And looking at those, your super LSR 15, 13, so your coronostat head is slightly less, and so those numbers make sense. Okay, now that the masses are more or less sorted out, now we can go to the next phase to say, how do we add the BMA data? So we want to get the equivalent BMA analysis into this space here. And as you can see, there's columns hidden here on top, but we'll address that now. So this is the total BMA, which includes the minerals as well as the elements. So let's go and fetch that. So your raw BMA is structured here. And what we want to do is we want to add the new BMA. So I'm going to open the file, which was all of the BMAs, and then there was additional blue ones. So let's go to raw BMA and say, right, these blue ones needs to, which is indicated in yellow here, needs to be added now to the sheet. So all that you do is simply copy that whole block of data up into there, which contains all the analysis, and you paste it into this. Remember to paste values. You remember you selected the Q number as well, and it's important to put that Q number, and you paste the values, and you just check, listen, is all of these things aligning? Yes, they are aligning. And then just take the same formatting that is here, just take that across by selecting your format painter and just dragging that all across there. Now your formatting is the same. Now what is very important is these labels that sits here needs to match now the labels that you have created inside there. So all of them, as you can see, so these are the labels of the submitted samples, but these are the labels that's in your structure. So you remember that you had a structure of one shaking table, 2 coronostats. So all of these numbers must just be slightly updated to match your new structure. Got 2 shaking tables, 1, 3 coronostat becomes 2 coronostat. To make a quick replacement if you have those, okay, this was actually 4 coronostat, sorry, so that must become 3 coronostat. And you can do the replace thing as well, but since it's just a few, I can do the quick replace there, find, replace, and say 5 coronostat, and you can make that small letters, doesn't matter, can be replaced with 4 CST, and this is just done to stick with the structure that you've created. Now if you go to your viewer extractor here at the bottom, okay, is you want to bring the following masses, you want to select them from your sheet and you want to get them out of your raw data. So if you paste them there, you see, okay, so there's no information, it doesn't see it, see this label. So the first thing that you need to do is just check if that masses are included, and they are indeed included. Okay, so the reference is correct. So now the question is just why is these labels not matching up with these labels on this side here? So let's have a quick look, and then you will see that there are 2 spaces inside that thing. So the reason why it doesn't match it is because of the spaces. So I need to take out the spaces, find replace, and say, right, just take out all the spaces there and replace them with nothing. Okay, so now you have removed the spaces from your true label that's going to get looked up, and you scroll down and say, there we go. So now these labels and structure is exactly the same as the labels and structure that's in your sheet to where you want to take that. So now you can simply take this whole array of data, which is from the beginning to the end, copy it and paste it inside this block, starting with the first. Now, as you can see here, there was multiple columns that were selected up to BG, and here, because the columns is hidden, all of these blocks are fitted in. So now a quick view, and say, right, the shaking table head there is made by those 2 and the coronostat head, okay, and that's the head calculation. Now, as you can see on these correlations, the correlations looks fairly good because what is it comparing it to? So it's comparing the coronastat head calculated with the coronastat head analyzed, and the same principle here. So based on the structure that you've already created, we do the error check. These numbers looks good. So what you've just done is you have just used available structure and you have pulled in your BMA data. It looks that the head analysis calculates nicely. Your correlations are good, so you can go to the next step. So I'm going to stop this video here and go to the part 3.